Hello, and welcome to Data Science Curriculum. My name is Dmitry Soshnikov. I am Cloud Developer Advocate at Microsoft and Associate Professor in a few universities in Moscow, where I teach. It is my great pleasure to welcome you to this Data Science Curriculum. And in this very first video, let's start talking about data and about what data science is. Data science is extremely important discipline because data surrounds us everywhere. Every text you write on the internet, every click you make is recorded somewhere. It results in some data being produced. And to be able to analyze this data is extremely important. So, what is data science? If we read the definition of data science on Wikipedia, we will see that data science is a field that uses scientific methods to gain knowledge and insights from structured and unstructured data and to apply this knowledge and insights in different application domains. So, what is most important here? First of all, the main goal is to gain knowledge and insights from data. Data is something raw. If you look at the table of clicks you made on the internet, they don't really make sense because it's a huge amount of information. But to be able to understand what interests you, for example, from those clicks, means gaining knowledge and insight. And this can be done using different ways. Secondly, it uses scientific methods. It means that data science is not about guessing. It's not about just computing average and taking it as a result. No, it uses proven scientific methodology to understand really what goes on inside the data. The data can be structured and unstructured, meaning that we don't only deal with beautifully formatted data, we can also take texts and videos and whatever data forms we have to gain knowledge and insights. And finally, data science is applicable across broad range of application domains. It means that you can apply it in many areas of business and many areas of your life, not only related to computer science as such. So, in short, data science is about using data to take knowledge and to take decisions. What are related disciplines to data science? Well, first of all, machine learning. Machine learning is a discipline that allows you to use data to build predictive models. Predictive model, in fact, is something that allow you to take decision automatically. And that's why machine learning is very closely related to data science because largely it solves the problem of data science of taking decisions. Another related discipline is artificial intelligence, which uses techniques of machine learning to try to behave like a human being. And whenever you have unstructured data, for example, when you have lots of texts, to be able to understand that requires human-like behavior. And that is something artificial intelligence can offer. Then big data. Very often data comes in really huge quantities. And this big data cannot even fit into one computer. You cannot easily process it. And there are special methods that allow you to use clusters of computers to parallelize this process and to make sense of these huge amounts of data. Databases is also a very well established discipline that studies how you can store structured data and how you can efficiently query them. Statistics and probability, as I have already mentioned, that presents the basic mathematical theory behind data science, and that is something we will briefly touch in this course. And finally, visualizations, how you can visually make sense of the data. So data comes in many different forms, and it can be structured or unstructured. Structured data, typically, you can think of it as a table with columns, so it's easily understandable, like you know where all pieces belong. Unstructured data, for example, it can be a collection of texts. And instead of reading them, you need to be able to make sense of this text automatically using some formal methods. Finally, there is also something in between structured and unstructured data, which we call semi-structured data. Consider, for example, Wikipedia. Wikipedia has a lot of text, but also it has links between pages. And those links between pages help you establish relationship between different concepts in this encyclopedia. So semi-structured data often comes in the form of graphs, for example, social networks and how people interact in groups. That is a good example of semi-structured data. So overall, the process of data science can be described as follows. You start with the data, and then normally you need to pre-process this data to make sense of it. And this initial data preprocessing can be done using many different tools. It can be done using database query languages or some programming languages like Python, and we'll give you a few different examples in this course. Once you build this easily digestible form of data, you can visualize it. And we'll talk a lot about visualizations, because visualizations, they are important to help people gain insights. Sometimes when you just look at the data which is visualized in the right way, you can immediately see the decisions you need to make. So visualizations will help you take decisions. Another way you can make decisions is by training predictive models using machine learning. So sometimes you can use the data to actually build the model that will take decision for you, taking all the data into account. And that is another side of data science. For example, we will consider the first example right inside this section of the course. And in this example, we'll try to figure out what are related disciplines to data science. We'll try to figure that out automatically using data. So we'll take the page about data science on Wikipedia. And this page is, because it's one page, it's mostly unstructured data. So first of all, we need to get this data. We'll download this data from source. And we will extract keywords using some artificial intelligence natural language processing techniques to get this nice table of frequently used terms. And this table can be then visualized, for example, in this bar diagram, and you will be able to compare which terms are more and which are less important. But this comparison is not visually clear. It's much better to represent the same thing using word cloud, because in the word cloud you can immediately see that data science is related to statistics, it's related to learning, it's related to science, computers, informations, and so on. And the size of the text indicates the relative importance. So this is the right visualization for this task, and we can immediately grasp which concepts are important and take decisions. For example, which concepts we should cover in our course and which we should not. So whenever you want to apply data science to some problem domain, you need to start thinking about two questions. First of all, where can I collect data? And secondly, which insights can I make from this data? And collecting data is a very important question, because in many practical examples in real life, we do not have data initially. And there could be many different sources of data. For example, data can be unstructured, it can be collection of texts, whatever people write on the internet, it can be collection of images. You can take, for example, your own photographic archive and think how you can process it to gain some insights about your past life. It can be logs, for example, analyzing logs of a web server can give you information about which pages are more popular, where people go, how long they stay on the page, and so on. Structured data often comes from some sensors. Internet of Things is a great source of structured data, because all the temperature sensors give you readings, and you can get that data and make insights and take decisions from that. Another example can be surveys that people fill after some events or after visiting your website. Finally, you can analyze the behavior of people. For example, clicks you make on the internet can be a good source of structured data, and it will give you a lot of information about persons' preferences. Finally, semi-structured data can come from social networks, from analyzing people's interaction in group dynamics. For example, if you have the large collection of photographs, you can see which people often take pictures together and build a graph of relations between them. So knowing all those different sources of data, you can immediately start thinking, okay, I can collect this data. How can that be useful? And by developing this kind of data-oriented mindset, you would be able to solve many problems using data science-oriented approach. In this course, we will give you quite a few examples of this approach and quite a few tools to be able to do that. I really hope you enjoy this course, and we'll see you later on in some other sections of the course. Thank you.